Hello, I'm Richard Hooper, and I'm pleased to be joined by Tony Radford, VP of Global Sales at Advantech Wireless Technologies. Tony, thank you for joining me today.
Always a pleasure.
Advantech was one of the SATCOM industry's first producers of solid-state amplifiers. How has the industry changed over the years, and where do you see your position today?
I think it's fair to say that, Advantech is a pioneer in the industry. We've been around since pretty close to the Stone Age. Hey, when we all started out, there weren't many players in this domain. The world of SATCOM, at least the amplifier part of it, was all driven by TWTAs and Klystrongs. There weren't enough devices available to be able to match their level of performance with solid state technology. But then, we all know over the years, the device guys have been hard at it, and they've given us some much better parts to work with. So I think the SSPA world is now pretty much head to head. There aren't many things you can do with a tube that we can't do with solid state.
Now, you say that Advantech specializes in amplifiers and amplifier systems that generate very high power. Why is this any different than producing amplifiers at the lower end of the power spectrum?
Well, as I mentioned, everything's built around these the transistors. We usually refer to them as devices because they're all different types. Like back in the day when they first started doing this, the devices were very low power. I mean, just a few watts, and it took too many. You had to cascade too many to get to a point where we could reach, respectable power levels, right? So it allowed the tube domain to continue on. But over the years, the tube technology has gotten, the device technology has gotten much better. But still, the devices, they're generally low power. They're much higher power than they were. You can buy anywhere from probably, in the more popular bands, aside from KA, you can buy, transistors that are above 100 watts. So you can still make pretty respectable power, even with a single FET. But us particularly here at Advantech, we don't come anywhere near stopping there. So in order to achieve respectable power levels, we need to cascade multiple devices, to get up to much higher power levels. And, that's a far greater challenge than working with a device or two. We've got amplifiers that have 20, 30 devices on them, all cascaded up.
I've heard you say that's a bit tricky in the past. How so?
Well, anybody that's been involved in the solid state world, I've been, worked for about 4 different SSPA companies, and there's certain conditions that are common to everyone, and that is that as you start cascading devices or phase combining devices, there's a lot of expertise that's required to do that well. It's much easier to say than it is to do, when you start putting these devices together, especially when you're matching, 6, 8, 10 devices in a single assembly, there are certain nuances that you have to go through to get these things matched up right. They, of course, all have to be in phase, as we all know, and they have to be combined very efficiently, because the parasitic losses that take over if you don't have efficient combining makes it a moot point, right? You've got to squeeze. You really want to squeeze as much power as you can if your actual goal is to achieve, really high power levels. And that's just the device level. If you want to go even beyond that, then we have to combine multiple amplifiers themselves. Now we get into whole new architectures where if you're shooting for thousands of watts, then that's just something that you have to go through. And it takes, the folks that have been doing this, particularly here at Advantech, they've been writing the book on device characterization and on efficient phase combining, on the construction or design of very efficient combiners, for decades. It takes a lot of years to build up the kind of expertise you need to be able to do that.
The recent announcement that you are shipping Summit 2 systems. What is the Summit 2 all about? Why is it needed?
Well, this is really a great one. As I mentioned, if you really want to get to the big power levels that the governments and some kind of specialty applications, deep space and all this, where they really want thousands of watts, even DTH. You've got to put a number of amplifiers together, right, to reach these thresholds. They're even at the amplifier level, the weight's got to be maintained. So there are, just certain parameters that you have to, that you have to stick to. And one of the problems when you're putting multiple amplifiers together is that if you're really going for big power, my experience, folks seeking really big power are carrying very important traffic, and they expect some level of redundancy, in the systems, which is to say, of course, that they can't afford for a failure of an amplifier to take their system out. The traffic's just too important for that. So in redundant systems, in simple redundant systems, that pretty much everybody does. If you have a 100-watt amplifier, you take another 100-watt amplifier and you put it into into a reserve mode where that backup amplifier is waiting for the online product to fail, whereby some Overwatch software will switch it into play, and then you're, with the exception of a glitch, as the system changes from amp 1 to amp 2, you're pretty well covered. But that becomes problematic when you get up into the thousands of watts. Because when you get to, if you're using really big powered amplifiers, you can't afford to have products sitting in stasis. If you have you're carrying 1,000 watts of power, having another 1,000-watt amplifier in reserve, becomes very expensive. And an amplifier is not doing anything unless it experiences a failure. And with the high MTBFs that you get in current solid state technology, the thing may be sitting there forever. So what Summit does is Summit, in a Summit system, there are no amplifiers that are carrying no traffic. Typically, a Summit system is comprised sometimes of 4, but more likely an 8 and 16 amplifier configuration. So, in the case of Summit, all 8 or all 16 amplifiers are carrying traffic, but there is enough of the output power held in reserve such that should an amplifier fail, there is no switch, so you don't get a glitch, and glitches can really be a problem. You get no glitch, you maintain a constant output, and the other 7 or the other 15 amplifiers will increase their power levels enough to compensate for the one that failed, right? So where if you have an 8,000 watt system like we recently deployed, if you've got an 8,000 watt system, you can't afford to have 8,000 watts sitting in reserve. I mean, you're talking hundreds of thousands of dollars. So in this particular case, 16 amp or an 8 amp system, all carrying traffic and ready to handle any kind of backup that's required. So no switch, so no glitches, and no amplifier sitting dead.
The fact that you're talking about the Summit 2 suggests that there was a Summit 1. When was it introduced, and what's the difference between the two?
Similar phase combined systems for Advantech dated back to like 2008, 2009. But the first soft fail system I know of that Advantech deployed before I got here was back in about 2013, and they put in 4 3,200 watt KU band systems using outdoor technology, which was unheard of at the time. Soft fail systems were available from other suppliers in a rack mount form, but nobody had put this kind of power out of an antenna before, which was it was unprecedented. And I think everybody viewing this that's involved in SATCOM realizes that when you start getting into higher frequencies, particularly starting in KU band, you're saving yourself a lot by putting amplifiers in close proximity to the antenna feed. So having an outdoor Summit system was great, right? Because now you've saved all that insertion loss that you have dealt with. You don't have a shelter, you don't have air conditioning requirements, none of those things. So it makes the application, very efficient. But that's that's Summit 1. And keep in mind that when you've got 8 or 16 amplifiers out there humming, and you've got an embedded operating system that's looking for issues on any of the amplifier level so that it can bring the other product online, so that it can alter the gains of the other products to maintain a consistent RF output. The software needs to be really fast, and in the old Summit 1 system, the software platform, of course, it was fine for the day, but in today's environment, it was far from the best it could be. So we had the team all queued up on what's called CAN bus, which is what your automobile runs on. In the case of a car, where you've got gizmos all over it. I mean, the car's covered with little devices here and there. You need a software system that will monitor all of the facets of the car in parallel and make adjustments to subsystems on the fly. In here, we took the CAN bus. We put there's got to be 1 million lines of code in that thing, but now the Summit 2 system operates on a CAN bus platform where everything is in parallel. So the speed, the performance, the recognition of any kinds of issues happens lightning fast, and is able to make adjustments very quickly on the fly. No collisions. It's much nicer, and we used a different hardware platform that's much lighter and smaller. So the one downside of the Summit 1 is it is a very big assembly. It's typically 8 or 16 very large amplifiers. In the case of the Summit 2, those amplifiers have been shrunk down in size by about 30%, and packaged in such a way that the footprint is probably, again, a good third smaller than the first Summit system. So it's, technologically, performance-wise, form factor-wise, it's light years ahead of the previous platform.
Apart from those very high power system, what's in the near future for Advantech? What are the challenges that you face?
Anybody who reads the news knows that the whole world is going K-band, right? So, and we've got, of course, competitors out there that have been, working K-band for a long time. Advantech used to have a K-band portfolio some while back, but one thing that's been kind of problematic for K-band folks is that the devices themselves have historically been a little bit unstable, and that's changing fast. All the chip guys, have been coming out with new parts. So, so we're relaunching our K-band product line, and have some very interesting combining technology that's homegrown Advantech. Advantech has quite a bit of passives experience in addition to doing just the RF modules themselves. Combining is super critical. The efficiency threshold we've been achieving in our K-band portfolio has been extreme. So we'll have some very nice, very high power, low power, high power, mid power, very efficient assemblies here. Going to be hitting the market here in the next matter of weeks. We've got the 5G. We have developed, actually, under the Alga brand. The team worked with the interference group, SES, Intelsat, and Eutelsat to produce a 5G interference rejection filter that all the satellite operators are using to deploy worldwide in their C-band networks. So we've been working really hard to get. We sell literally thousands and thousands of these products. So we've been working to increase our production throughput to get this where it's needed to be. That and the stuff that we're doing with Summit 2, and we got the hopper's full. We got plenty of stuff to do.
Sounds very interesting, Tony. Thank you for talking to me today.
Very much enjoyed.